Hey, I just wanted to look at some of the other evidence that came out after World War II. So during World War II, the Allies developed a technology called a fathometer. Fathometer was used to measure the depth of the ocean floor. It's like an echo sounding device, like a sonar. And one reason they developed this was to detect enemy submarines. The Germans had these really bad U-boats that were destroying our shipping. And so they could detect those, but also to see how deep the water was so that if you were a troop ship commander, let's say, that you didn't have a problem where you would run aground somewhere, because that could really be a problem in a war. So they developed this technology to measure the depth of the ocean basins, and one troop ship commander named Harry Hess kept his fathometer running all the time. Regardless of whether he was in enemy waters or in deep water, because in civilian life, he was a Princeton professor and a geologist. And so Harry Hess, after the war, and others, adapted this technology to be used for scientific purposes. So if you traverse the ocean using a fathometer, you get an elevation profile that looks something like this. This is across the North Atlantic. And what you can see is some interesting features. First of all, there's the shallow water adjacent to the continents. That's the continental shelf. And when you make this the edge of the continent, then the fit of the continents gets a lot better. And then you have the deep ocean floor, known as the abyssal plain. And then there are these little seamounts here, occasional little cones that pop up on the ocean floor. But then you also have this interesting feature here, which is the mid-ocean ridge system, which is basically a really long mountain range that winds through all of the different ocean basins. And it's right in the middle of the Atlantic, which is interesting. And so this was one of the features that was discovered on the floor of the ocean that led Hess and others to propose the seafloor spreading model of plate tectonics. Let's close that one and we'll see some other information that came out. So if we go over to the Pacific here, and we can look at this trench here. So this is another thing that was discovered, is the Mariana Trench and other trenches. And again, we can show an elevation profile here. And what you can see is here's the flat ocean floor, another seamount here and here. But then it goes right into this very deep ocean trench. This is over 6,000 meters deep, which is very, very deep. And then on the other side of the trench, there's actually a chain of islands right here. These are the Mariana Islands. And these are all volcanic islands, which is interesting. So this was another interesting fact that was discovered on the floor of the ocean. And then another thing that was discovered on the floor of the ocean were all of these seamounts. And you can see one of the most famous examples right here. This is the Hawaiian chain. So you have the big island of Hawaii here. Oops. Zoom in on that. The other islands in the Hawaiian chain. And then you have these flat-topped seamounts here, which are called guios. And that continues here, and then it makes a right angle change here, or almost 90-degree change, and heads up towards this trench up here, which is the Aleutian Trench. And so the existence of these flat-topped seamounts was also kind of a key piece of information, especially because they occur in these lines. And what we're going to learn is that these show the movement of the plates, that there's a hot spot here, and that as the plate moves, it's going to be carrying those volcanoes off of the hot spot, and then they eventually erode and become these seamounts. So that's some of the information that was used during the time when we were trying to prove the seafloor spreading hypothesis.